to everyone. It's really exciting to be here, and it's such an honor to be able to join in these conversations that you've been having. I sat in a few sessions yesterday, and the diversity of topics that you're all working on at the county level is really impressive, and hopefully this will give you some more information and things to chat about. I'm here from NASA's Ocean Ecology Lab, and I'm going to tell you a little bit about NASA Earth science in general, and then also a big focus on climate and where we are with the science and how do we know what we know. So you want to feel really comfortable and confident, and when you're hearing numbers, you're hearing data, like how do we actually know that? It's not just a number on a graph. We work really hard to make sure it's accurate and meaningful to everyone. So that's what I'm going to be talking about today. I started with this image. So this is our system at NASA Earth Science. This is our planet Earth. This is a picture from September 7th. So just 1 week ago, this is what the Earth looked like from 880,000 miles away. So there's a satellite way out there called Discover, and it takes daily images of the Earth. So we can look back and see what's going on. And when you look at this image, here's what you want to take note of. This is all the moving pieces, all the parts of the puzzle. So you have the atmosphere, you can see the clouds, you can see Hurricane Larry right here in the middle. This is tough with two screens, but here's Hurricane Larry right there in the Atlantic coming our way. You can also see the ocean. So we're primarily covered by water, so some people joke it should have been called Planet Oceans instead of Earth. But the oceans are a very important system when we're thinking about climate. We talk a lot about the atmosphere, what's going on, but the oceans are moving lots of heat, lots of energy all over the place. And then of course we have land, where we all call home. So you can look on these images, and if you look on the west coast of Africa here, you can see how these systems are interacting, because you can actually see dust from the Sahara in the air. So the winds are blowing the atmosphere across the land, and then that's ending up in the ocean and fertilizing the ocean and letting things grow. So keep in mind, a lot of times when we talk about climate, it feels huge and overwhelming, but this is it. This is the system. This is what we're working for. So, that's what we're working on. All right, big talk. It's always fun when we get everyone together to start with an icebreaker, right? So here we are. Different type of icebreaker than maybe you're used to starting with, but I am an oceanographer, so I wanted to get this out there. When you're looking at these graphs and you're like, okay, you have satellites flying around in space, and then you're trying to tell us about the Earth, you might be wondering, how do we know if the satellites are even keeping things, are they even right? So we go out, there's a lot of scientists like me on the ground, and we go out when the satellites are going over. We take measurements to make sure what we're measuring from space matches what we're getting on the ground. So that's a huge part of what we're doing at NASA as well. And if you're ever wondering what it's like to be on an icebreaker, I have that experience for you too. So this is the front end of that boat that I just showed you. This is the Palmer. It's one of our research vessels. This is in the Southern Ocean. It's a boat I've been on for 42 days on the Southern Ocean. And on the bow there, this little instrument is measuring. It's one of our oceanography instruments. So it's measuring light just like the satellites do. And here's what a good day at sea is like. Nice blue skies, and some swell out there. So anyways, that's what we're up to on the day-to-day. So thought you might enjoy that experience. Probably once is enough, you just had breakfast, but anyways, so just keep that in mind. We have people on the ground, as well as the tools, the satellites, the instruments out in space. All right, so the planet has been showing us signs of change. You've heard a lot about glaciers. This is a glacier in Alaska called the Muir Glacier. The photo on the left is from 1941, and then the photo on the right is from 2004. So, we're seeing signs of change. You don't even always need fancy instruments, things like that, to tell us. You can just look around, and wherever you go where there's glaciers, you're seeing the same type of pattern. So this is something we've been observing. And even in our own lifetimes, you've probably noticed, you used to walk uphill both ways to school, or the winters were so much colder. And I have that version of a story. So I grew up in rural Wisconsin, and we grew up on a little lake, and we used to spend all of our winter holidays skating, sledding, all of these things. This is a picture from 2009, out playing some hockey on the lake. And our tradition as kids when we were little was on Christmas Eve, we would load our sleds with presents and food and everything we needed for Christmas Eve. And we would go to a family that lived down the lake and across the lake. So we would load our sleds and we would walk on the ice to this family's house. Never ever ever thinking that there wouldn't be ice. So last year I went back to visit my family, and this is what I was doing on Christmas morning. So I was out on a kayak ride, which is truly unbelievable for me. So even in our own lifetimes, we've been noticing changes. But obviously this is not how we do science. We don't just tell stories, oh, remember, things like that. But it's good to reflect back. And some of the changes we're seeing, those are real. All right, so we're gonna put this up. This is just showing the temperature trends since 1880, since the beginning of the Industrial Revolution. And the climate is warming. So you can look on the bottom is time. And then on the far edge, or on the left side, is temperature. So the different color lines are just different research groups that have recreated the temperature trends. And you can see they overlap pretty closely. Oops, that is not what I want. Older, back in the day, there's not as many measurements, so there's a little bit of separation. But as we move into present day to 2020, all those different groups are ending up in the same spot. So we see a global warming average of 1.2 degrees Celsius or 2 degrees Fahrenheit. So keep that in mind. So we can measure this warming, we can see this trend. So the next question is, why is this happening? All right, and the warming is being driven by greenhouse gases. We're gonna break this down, but this graph actually goes back 800,000 years. So they're using gas trapped in the ice caps that you can measure. So you can see, and then the dashed line where that arrow is 1950, and you can see this dramatic increase in CO2. And we can zoom in a little bit more. So here you're gonna see the global temperature, that's the blue bouncing around from 1860 to present. The orange dots are modeled CO2 estimates, and then the solid line is actual measurement, modern day measurements. So you can see the model that goes back a little further is aligning very well with what we're actually observing. And you can see how that CO2 is trending with the temperature. The same is true with methane, same patterns that we're seeing. So methane is considered the second most important greenhouse gas after CO2. And you can see these same trends, severe increase in modern times. Now, there's other things that people talk about that might be driving warming, right? So here's a graph of temperature on top. You're gonna get used to seeing this pattern with the line, with the steep increase starting around 1970. And on the bottom is the solar cycle. So you hear a lot about solar cycle. The solar cycle is 11 years, so these little dots are the year to year. The bold yellow is actually the 11-year average. So it's averaging what we're seeing with the solar cycle. And you can see back in the 1860s up until about 1950, those tend to trend together. So you can see, you see warming when you see increase in solar irradiance. So yeah, those tend to trend. But you can see when they start to separate, which is in about 1970s. So that solar pattern is not what's driving the warming that we're seeing. And in fact, it's cool, it should be cooling if you're following the solar trends. So these are the things that we put together, all these different observations. You can do this with volcanoes, you can do it with, orbital tilt, all sorts of different variables. And this is what we end up with. So this is a busy graph, and I'm gonna talk you through. I think it makes a really big point, and this helps with confidence in the science. So the black line is that warming line again. So you have it bouncing up and nice and steep here. So we're gonna start at the bottom with kind of that greenish blue. This is the model. So you can see back here in the 1850s, when these models were first run, the temperature and what we observe and what we're modeling are pretty close together. So this is the natural cycle, this blue one. This is the solars, the volcanoes. You can see these big dips in temperature that would be predicted because of the volcanoes. So all of this is put into the model. And then the brown line is the natural combined with what the humans are doing. So greenhouse gases, deforestation, those things that we are contributing. And again, back here, what we were up to and what naturally was happening and the temperatures observed were trending. And then you can see this separation. So we would have a little bit of warming if we only had the natural cycle going on. This is where we would be. You can see it's slightly above that 0 line. So even if humans weren't here, sure, there'd be a slight amount of warming occurring. But this amount of warming that we're seeing, that black line can only be reproduced if we put in human activity. So that's what you want to do. This is how we're trying to figure out what are the actual drivers of these trends that we're seeing. NASA, we have all sorts of satellites that are helping us better understand these trends. We're modeling all different things. Oops. And so these are our current fleet. This is just from a couple weeks ago. We have 29 satellites going around the Earth, and this is just NASA. So there's other satellites from other agencies, European Space Agency, etc. And all of these satellites are measuring different things that are going on Earth. So some are measuring, CO2, some are measuring water quality, some are working at land use changes, soil moisture. There's a huge suite of different measurements that we're making every day to kind of keep our eyes on what's happening on the planet. So these are the types of data sets that we have. Full global coverage and all sorts of different variables that we're putting in to gain understanding. So one of the neatest things we get from the satellites are just really beautiful imagery. So these are the types of pictures we can get from the satellites. I can talk you through. So that top left one is California coast and the Pacific Ocean. So again, you can see the clouds, you can see that near shore, there's lots of stuff growing in the ocean. Here's the Greenland ice sheet, so you can see that. Again, the interactions between the land and the oceans. This middle one, top, like on the right, is the coast along Louisiana and Alabama, so that's the Gulf Coast. Here we have the east coast of the US with the hurricane off in the distance, so you can see that. And then the bottom image is just the North Atlantic. So it's pretty amazing the type of details that we're getting and what we can see when we're looking at these data sets. And again, the satellites are showing us the same types of patterns that we were seeing on the ground with our own photos or our own observations. So this is a glacier, the largest glacier in Greenland, and it's just comparing 1986 to 2020, and you can see this big chunk of the glacier has fallen off. That's 44 square miles, so it's a huge amount of ice that has fallen off. So anywhere you go and you look at glaciers, you're going to see these same patterns. This is Lake Mead, so comparing 2000 to 2021. So currently Lake Mead is at the lowest level it's been at since they've built the dam. So we can see these changes happening. But you don't just have to take one time period and compare it to the other. We have these data sets that go back 50 years, so you can watch year to year the slight changes that are changing over time. So this is actually Arctic sea ice. So the white floating sea ice. And these are images from year to year starting in 1979. So you can actually watch how the sea ice has changed from images that we've gotten from the satellite. And the graph is just showing the sea ice loss through the times. So you can just watch how it slowly goes smaller and shrinks away. If there's any sailors, there's a great Northwest Passage opening here. That's 2012, that's when we had the least amount of sea ice. And actually last year they had boats sailing up to the North Pole with very little resistance. Still in icebreakers, but they actually got to the North Pole, which is something that wasn't predicted to happen for a while. So we can be watching these changes. A really big important variable that we're also watching is the ice sheets and how they're melting. So again, this is the Greenland ice sheet. The graph is just year to year, and you're watching the rate of the ice sheet changing. So it goes from white to yellow to orange to red. When it gets to red, that's about 16 feet of ice sheet. So again, these are observations that we're actually making. These are not models. We're watching this happen in real time, which is pretty powerful. So the ice sheets melting is a really big deal because this is a huge contributor to sea level rise. The sea ice is already in the ocean, so when it melts, it contributes, but not in the same way. These ice sheets are actually up on land, so when they melt, that falls into the ocean, and that is a big pusher for sea level rise. And then, speaking of sea level rise, we have this graph here, so you have, again, time on the bottom, and then sea level rise change on the side axes, so you can see that. And this goes back to 1900. So you can see we've had steady sea level rise. The orange line represents when we added satellite data, and you can see it's getting a little bit steeper. And that's one of the predictions with climate change is the rate of sea level rise will be getting faster and faster and faster. All right, so you might be looking, you might be looking at this and saying, all right, 2 degrees, that doesn't seem too big of a deal, and I don't live in the Arctic, so that's okay. maybe this isn't something that we really need to think about too much, but you really need to put 2 degrees global change into context. So if you think about the last ice age, when we had glaciers from the North Pole all the way down to Brooklyn, that temperature change was 8 degrees. So that was a massive change in the state of the Earth at 8 degrees. So we're a quarter of the way towards that, but in the opposite direction. So, you know, we can think, oh, well, today's 2 degrees warmer than yesterday. No big deal. But it's a huge amount of energy if you're warming the entire planet 2 degrees. So that's changing these systems. So you don't always want to just think about the means, this 2 degrees, but you want to think about how this change in the mean, the average temperature, changes extremes. And those are the things that really impact our lives, right? Those are things like, heat waves. So we can see these heat waves from space. And these are also increasing. So these are the things, this is like a 2 degrees on average, but it leads to events like this, 30 degrees above average on a certain day or for a few days in a row. So we have these more extreme events just because we have a little bit of a change in the mean. So keep that in mind when you're thinking about climate change. And along with heat waves, we also have drought intensity. So you can look at a map like this. This is just from last week, September 6th, and you can see this is based on soil moisture, which is an indication of drought. So you can see the West right now is in a drought, what they're considering a mega drought. That goes back to that photo of Lake Mead. Super dry out there. And then you can see other parts in the country are having lots and lots of water. So you can look at the South right now, hurricanes, keep hitting them. You can look up in your area as well. You can see it's pretty wet in a lot of the state, although that top edge looks like it's staying a little bit dry. So we can look at these patterns and we can see how these are changing through time. And drought is one of the big predictors with climate change as we move forward. So this is actually just the future projections with different emission standards. So if we keep low emissions versus medium versus high, you can see the more brown and orange we get, the more extreme these droughts are. And primarily what we're seeing the changes is not these single year droughts, but they're predicting a lot more of the extended long droughts, which they consider at least 21 years in length. That's what the big predictions are for. So it's not just getting through one tough year, but many years in a row. So if we have hotter and drier, we also have wildfires. So again, we know the West especially is having some trouble with the wildfires, although I was just back in Minnesota, and we had a big wildfire in the Boundary Waters, so right on the border with Canada. They're also in a drought right now. So, you know, these are far away, and I know you all know, but one thing to keep in mind is that how this impacts air quality, right? So all sorts of different parts across the country this year had some of the worst air quality that they've had, you know, on some of the records. And this is all driven by the West Coast fires coming across and, you know, impacting our air quality. So these are things that we expect to see more of in the future as well. This is also an interesting image because you have the wildfires and moving the smoke, and then there's actually 2 hurricanes off the coast. This is from last year. So it shows a lot of the different systems kind of interacting. And so another big prediction is the intensity of storms. So we talk a lot about, you know, hurricanes and things like that, but what they're really focusing on with the changes is the intensity. So we might not have more hurricanes or more rainstorms, but when we have them, they're going to be much more intense. So that 2 degrees, that extra energy, leads to a lot more evaporation. So there's a lot more moisture in the air, and so when it falls down, it can fall down very quickly and in a very intense way. So it changes the way we have to interact with these storms because they move the water through the system in a different way. So this is from Tropical Storm Henry, which all of you know about, and you can see we had a pretty wet summer already, and then that fell very quickly. And then just to have those records broken the next week or 2 weeks later by Ida. So again, we might not have more storms, but the storms are more intense and they're dropping more water in a very quick fashion. And that's all because of the rate of evaporation and that little bit of warmer energy in the air. We also see changes in things like vegetation. So ecosystem changes, right? This is the Arctic. This is 29 years of data from a satellite called Landsat. And anywhere you see green, you can see that it's actually greening. So it's going from maybe snow cover to more plants and things like that. So this is just a change. Sometimes when we talk about this, people are like, that's gotta be good, right? Like more plants growing. And that's not our decision to say if it's good or bad, it's just to say, it's changing, the systems are definitely changing. And that's gonna lead me into another system that we talked about earlier, which is cyanobacteria, which I know is a big issue here, so we're gonna spend a little bit more time talking about this, and some of the tools that we might have that might be useful. Martha mentioned these cyanobacteria, these blue-green algae, are growing in lakes, and a lot of people have been noticing kind of an increase in the occurrence of these blooms, and a lot more awareness of that they're happening. So these can be an issue because you're no longer allowed to swim or paddle. We're really interested in it because a lot of the lakes are drinking water supplies, and we need to know if there's a toxin in the water. Other people just go out hiking with their dogs, and the dogs jump in, the dogs can get sick and die. So there's a big need for awareness of what's going on. So this is a project that we're doing right now, using the satellites to monitor for these types of events. So what we're providing is every day or two, I'll zoom in on this so I don't get overwhelmed, but we're doing a full map of the US every day or two, which estimates cyanobacteria. So all the brown is land, and then you can see all the speckling around, and those are different lakes across the US. So there's nearly 3,000 lakes that we can look at. If you see gray, that means we're getting measurements, but it's below a level that we can really detect. So very low level or no cyanobacteria in the water. So we're providing these tools. You can zoom in on different regions. You can see here, this is over in Wisconsin, Lake Winnebago's got some, Western Lake Erie, things like that. So this is just from last week. This is what we were seeing last week, looking at the cyanobacteria across the region. And then I zoomed in here on the Finger Lakes in this area of New York, which are looking pretty good right now, according to what our satellites are seeing. So gray means that we're not getting a high level of bacteria. So this is a really cool product that's available. And you can go and interact with it and look at it and look at your lakes. I'll get into some other details, but these are the types of products that we can provide. So this is just bloom frequency. So if you have a state level, you can look at it from state to state. So blue, each shape is a different state. So you can see New York up here. So blue means that there was not a measured bloom when the satellite went over, and then light green means a low bloom, and then to very dark green, which is a high bloom. So you can take these satellite images and you can actually look at frequency for a state, or you can do this at the county level or at the lake level, any level that you're interested in. And then you can compare year to year. So this satellite data goes back to 2002 until present day. So you can actually look at different trends that you're seeing. One thing that they did in Florida is looked at bloom frequency over a 4-year period. So this is a map of Central Florida. They took all the satellite data that they got for 4 years, and they just colored the lake. So if the lake is blue, it means they never had a bloom over those 4 years, up to yellow, which means anytime they got satellite data, there was a bloom. So this is a really informative way to look at the data. And if you have limited resources, you can figure out which lakes are the problems. And you can also figure out when did the lake become the problem. Maybe it was fine in 2002, and in 2012, something happened, and now it seems like it's more of an issue. So this is a really cool data set that I think would be useful for a lot of you that are dealing with lake water quality. Another nice thing with this data set is that it actually comes as an app. So it's something you can get in your hand anytime you want. So if you're trying to go canoeing and you have it on your canoe on your car, you can actually look at the lakes around you and figure out what's going on. Another neat feature with the app is if you drop in a pin, it will tell you, so green is good, yellow is not so good, and it goes to red, which means probably not a lake you want to go to. But you can also look at time series from the lakes. So you can see how has the lake changed over time. So all of that is available in the app. And you can take these types of data and you can actually, also tie these to different other changes you might be seeing, like these intense rainstorms. A lot of times when you have these big rainstorms, they move water through the system in a different way, and that might be impacting the types of blooms you're having or the severity of the blooms. So there's a lot of different variables that can be tied together. All right, and this is just another slide about the validation. We started with the icebreaker at the beginning, but I wanted to let you know a little bit more about how we're validating the data. It's not just out on the icebreakers. There's all sorts of autonomous robots that are out swimming around taking measurements that we're matching up with the satellite data. We're going out with actual nets onto lakes, things like that. And this is the water focus. For all aspects of any of the NASA products, there's an equivalent of this. So all the atmosphere folks, they fly on their planes and take measurements, they have drones. There's all sorts of different ways that the data is being validated. So it's really important to keep that in mind. This isn't just, random measurements in space, but there's actually a lot of people on the ground confirming what we're seeing. All right, another thing that people are really interested in when we talk about these big events, something like a hurricane. How do we know that it's caused by climate change? There's always hurricanes, so how do you can't say like this hurricane definitely was climate change and this one wasn't. How do we talk about the attribution? How do we know what's causing what? Or are things just getting worse? How are they changing? So this is a really great website. It's called the Carbon Brief, and what it does is it actually takes different events that occur, and then they do different attribution studies to figure out how do we know what part of this was caused by climate change or what wasn't. So these are all different, hurricanes, flooding, wildfire, different events. Wherever you see red, that means they studied an event and that they attributed that to human behavior or some sort of human influence. And where you see blue, that means it doesn't seem like this is being at all driven by climate change or anything that human behavior is up to. So you can actually click on different events and learn about how do we attribute different things. So one example that I found for New York is they're talking about the city street, the flooding in New York. So is this just normal flooding, or is something that humans have been doing driving this? And so you can actually click on an event and it explains, okay, yeah, sea level rise and these intense storms are contributing to the flooding we're seeing in New York. And then it actually lists the science study that came from. So it actually shows where the data's at, how you can learn more about how they made this decision. Another really interesting one that you can click on is Hurricane Harvey. So Hurricane Harvey was this huge, rain event that occurred. And yeah, just like we all know, there's always been hurricanes. And so what they did when they studied Hurricane Harvey is they said, all right, well, the Gulf of Mexico is this much warmer than it would have been, about 2 degrees. And so they can then figure out, well, if it's this much warmer, how much extra moisture is in the air? And then how much extra rain would that lead to? So they contributed 20% of the excess rain in Harvey to climate change. So they can break it down to different levels like that. If it wasn't so warm, there wouldn't have been as much moisture. So it's not saying that that hurricane would never have happened, but it's worse than it would have been because of those different attributions. So this is a great website if you're interested in how to figure out where that is coming from. That was a lot. All right, well, I'm already on my conclusion slide, so we're gonna have lots of times for questions. So before I talk about the actual conclusions, I wanna explain that figure. So this starts in 1997. It's a monthly composite of what's going on the planet from 97 until present day. And you can see these cycles from year to year. So you can see the snow and ice coming down when we get to winter in the north. You can watch the phytoplankton growing in the oceans, those seasonal trends. You can also watch the plants come and go on land. So these are really impressive global data sets, and it's being able to put all these pieces together that allows us to understand what's going on with our climate. So you can just watch that, and then I'm gonna say my conclusions, but you can just zone out and watch the pretty pictures too. But, all right, so the planet is warming. We can tease out that human behavior is pushing this warming. And again, we have about 2 degrees Fahrenheit change. But it's not just that it's 2 degrees warmer, it's that this really changes extremes. So we're seeing a lot of increases in storm intensity, bigger rainfalls, wildfires, heat waves, not just on land, but also in the oceans, and then drought intensity. We're seeing fewer cold snaps, so maybe some people think that's a good thing. So there's different changes. Not all things are getting worse, or it's every single extreme has a different, climate change has a different impact on every extreme. So you have to look at each type and figure out what's going on. There are tons of tools available. So all the images that I showed, most of the images I showed today are from NASA Climate. So you can check out all these images. Every single image has tons of more information, so you can learn anything you need. We have more regional studies. We have a huge applied science, so if you have an issue that you want someone to try to help you with, you should come and ask. We can do all that. I know it's overwhelming, there's a lot going on. There's tons of information, and we would love to share it with you. So don't be shy about reaching out to us or the other agencies as well. And then, that's it. So this is the planet Earth from September 10th, so just a few days ago. And I encourage you to go to the Discover website. You can check out these images every day. So with that, I'm happy to take any questions. Thank you.